Hello, friends. Welcome to my workbook. We practice maths together in this channel. If you're a class 10 student, this is the right place for you to practice maths. I have uploaded chapter wise videos where I have explained theory, solved multiple choice questions, sample papers, questions from previous year board exam. So, if you are new to the channel, please subscribe and check the playlist. You can pick a topic of your choice and start practicing right away. In this video, let's practice chapter 4 quadratic equations in class 10 max. I have chosen questions that were asked in the board exam in the years 2015 to 2019, so last 5 years, and let's practice by solving those questions. Before we start with the sums, let's quickly revise the key concepts. So a quadratic equation in the variable x is of the form ax square plus bx plus c is equal to 0, where a, b, c are real numbers and a, which is the coefficient of x square, should not be equal to 0. A real number alpha is said to be a root of this equation if a alpha square plus b alpha plus c is equal to 0, which means if alpha is a root of this equation, then if we substitute alpha in place of x, the equation has to be satisfied. Then alpha will be a root of this equation. Now, how to find the roots of the quadratic equation? There are different methods: factorization or splitting of the middle term, completing the square, and quadratic formula. So any of these three methods we can choose to find the roots of a quadratic equation. Quadratic formula. Let us see what is the formula to find the roots of the quadratic equation. If the equation is in the general form ax square plus bx plus c equal to 0, then the roots are given by minus b plus or minus root of b square minus 4ac divided by 2a, provided that b square minus 4ac is greater than or equal to 0. So this term within the square root b square minus 4ac is called the discriminant of the quadratic equation. So we can find the roots by using this formula whenever the discriminant is greater than or equal to 0. So if we find the discriminant of the quadratic equation, we can tell the nature of the roots. If the discriminant is greater than 0, then the roots are real and also distinct. So there will be two different numbers, two different values of roots. If d is equal to 0, then the roots are real and they are also equal. So the roots are coincident. So you'll have only a single value which will be the root. Both the roots will have the same value, and the value of the root is minus b by 2a because this discriminant reduces to 0. Hence we are left with only minus b by 2a. When the discriminant is less than 0, then the square root of discriminant will not be a real number, so the roots are not real. So when discriminant is less than 0, there are no real roots. So these are the key concepts. Knowing this, we'll be able to solve the questions that I've chosen. What I observed is most of the questions from this chapter has been framed based on the quadratic formula and these three scenarios. As in, based on the discriminant, we'll have to tell whether the roots will be real or distinct or equal roots, or will there be no real roots at all. So be very clear with the formula for finding the roots of the quadratic equation and how to find the discriminant for a given quadratic equation. Come on, let's proceed. Before we proceed, if you're yet to subscribe to my channel, kindly subscribe and also press the bell icon so that you receive updates as and when new videos are uploaded. So this is the first question. As you see, it is a 1 mark question that was asked in the 2019 board exam. Find the values of k for which the quadratic equation 3x square plus kx plus 3 is equal to 0 has real and equal roots. Answer is already given at the bottom end of the screen. So you can do it by yourself if you're confident and check the answer alone. Now, quadratic equation is given and we need to find the value of this k if this quadratic equation has real and equal roots. So, what is the condition for real and equal roots? D, the discriminant should be equal to 0. So, b square minus 4ac has to be 0. B is k. So, k square minus 4 times a is 3 and the constant c is also 3. So we have k square minus 4 3s are 12, 12 3s are 36 equal to 0. K square is 36. So k will be square root of 36, which can be both positive or negative 6. So the value of k will be positive or negative 6. So this is for 1 mark. Next question. For what value of k does the quadratic equation 4x square minus 12x minus k is equal to 0 has no real roots? Again, it was a 2019 board exam question for 1 mark. So for no real roots, the discriminant should be less than 0. So b square minus 4ac will be less than 0. B is minus 12, so b square will be 144 minus 4 into a is 4 and c is minus k. This has to be less than 0. So 144 plus 16k is less than 0. So k should be, or 16k should be less than minus 144. So k should be less than minus 144 by 16. This goes 9 times. So k should be less than minus 9. This is the value of k for which the equation has no real roots. Moving on. Write the discriminant of the equation x plus 5 the whole square is equal to 2 into 5x minus 3. It was a question asked in 2018 board exam for 1 mark. Now to write the discriminant, first the equation has to be in the general format, which is ax square plus bx plus c equal to 0. So we need to first arrange the terms in this generic format. So let's expand x plus 5 the whole square. X square plus 10x plus 25 is equal to 10x minus 6. Both the 10x will get cancelled. You will have x square plus 31 is equal to 0. Now we observe that there is no x term, so b is 0. A is 1 coefficient of x square and the constant c is 31. We need to find the discriminant. It is b square minus 4ac. B is 0 minus 4 into a, that is 1, and c is 31. So minus 4 into 31 will be 124. So the discriminant is minus 124. Next sum. If the quadratic equation px square minus 2 root 5 px plus 15 is equal to 0 has two real and equal roots, find the value of p. So this is again a 1 mark question from 2015 board. For real and equal roots, the condition we know it is discriminant has to be 0. So b square minus 4ac to be 0. B square is minus 2 root 5 the whole square minus 4 into a is p and c constant term is 15. I have missed this p here, 2 root 5 p. So here you will have a p. This is the discriminant which should be equal to 0. So squaring this entire term you will get 2 square is 4, root 5 square will be 5. So 4 into 5 20, 20 p square minus 4 into 15 60 p is equal to 0. Let's divide it, or we can pull out 20p as common. P minus 3 equal to 0. So it's a product of factors. Two factors are there. We can equate 20p to 0. So p will be 0, or p minus 3 is 0. P is equal to 3. So this is the value of p for which the quadratic equation has equal and real and equal roots. Next, fifth sum. Find the roots of the equation root 2x square plus 7x plus 5 root 2 equal to 0. This is a 2 mark question which was asked in 2017. So we have been given a quadratic equation and asked to find the roots. Which method is not mentioned in the question, so we can use either or any of the three methods that we discussed. Equation is root 2x square plus 7x plus 5 root 2 equal to 0. Let's choose splitting the middle term. This 7x, let's split it up as 5x plus 2x. So I'm splitting the 7x as 5x plus 2x. Now I can pull out x as common. So I'll be left with root 2x plus 5 from these two terms. In the third and the fourth term, let me pull out root 2 as common. So I'll be left with root 2x plus 5 is equal to 0. So root 2x plus 5 plus x plus root 2 is equal to 0. Sorry, there's no plus. It's product of two different factors. Root 2x plus 5 into x plus root 2 is equal to 0. So we can equate each of the factor to 0 and arrive at the values of the roots. Either root 2x plus 5 should be 0, or x plus root 2 should be equal to 0. This gives x is minus 5 by root 2. Normally, we do not leave the denominator as the square root of any number, so we will rationalize it. We will get it as minus 5 root 2 divided by 2. So this is one of the root. The other root is from this part. This implies x is equal to minus root 2. So the two roots are x is equal to minus root 2 and minus 5 root 2 by 2. These are the two roots for this quadratic equation. Let's move on to the next sum. Find the value of k for which the equation x square plus 2k into 2x plus k minus 1 plus 2 equal to 0 has real and equal roots. So for real and equal roots, we know the discriminant has to be equal to 0. Before finding the discriminant, let's rearrange the terms in the quadratic equation to the common format ax square plus bx plus c equal to 0. So the given equation can be written as x square plus 2k into x plus 2k, no sorry, plus 2kx plus k square minus k and plus 2 is equal to 0. So this fully is the constant and this is your x term and x square term. Now for real and equal roots, we know that discriminant should be equal to 0. B square minus 4ac should be equal to 0. B is the coefficient of x, which is 2k. So 2k the whole square minus 4 into a is the coefficient of x square, which is 1, into c constant is the entire term k square minus k plus 2. This discriminant should be equal to 0. So if we expand and if we solve for k, we will get the value of k. So 2k square, 4k square minus 4 into k square, 4k square plus 4k minus 8 is equal to 0. It's cancelled. So we have 4k minus 8 is equal to 0. So k will be 8 by 4, which is 2. So k is 2. Next, 7th question. If minus 5 is root of the quadratic equation 2x square plus px minus 15 is equal to 0, and the quadratic equation px square plus x plus k has equal roots, find the value of k. Now there are two different quadratic equations and the term p is appearing in both the quadratic equations. We have been asked to find the value of k. So let's first solve for p from the first condition. If minus 5 is a root of the quadratic equation 2x square plus px minus 15 is equal to 0. So the given equation is 2x square plus px minus 15 equal to 0. Minus 5 is a root of this equation. So if we substitute minus 5 as the value for x, this equation will be satisfied. So 2 into minus 5 square plus minus 5 into p minus 15 is equal to 0. 5 square will be 25 into 2 is 50 minus 5p minus 15 is equal to 0. From this we can find the value of p. 50 minus 15 will be 35. So 5p is equal to 35, which gives p as 7. So we know the value of p. So we can substitute p as 7 in the second equation. 7 into x square plus x plus k is equal to 0. which is 7x square plus 7x plus k is equal to 0. Now we need to find the value of k if this equation has equal roots, which means for equal roots, discriminant should be equal to 0. B square minus 4ac equal to 0. B is 7, so 7 square is 49 minus 4 into A is 7 and C is K. 4 into 7 into K is equal to 0. 49 minus 28K is equal to 0. So K will be 49 by 28, which is 7 by 4. So the value of K is 7 by 4. Next, eighth sum. Solve the following for x. 4x square plus 4bx minus a square minus b square equal to 0. It's a 2-mark question which was asked in 2015. 4x square plus 4bx minus of a square minus b square equal to 0. So if we rearrange these terms, we can write the entire equation as a product of two factors. So factorizing would be easier for us. Before that, we will recall a couple of algebraic identities which will be useful in this question. First, uh, p plus q the whole square. How do we expand it? P square plus 2pq plus q square. And if it is p square minus q square, it can be written as p plus q into p minus q. So let's first rearrange the terms here. 4x square plus 4bx. Since it involves b, I'm bringing the b square closer. So minus of minus b square will be plus b square minus a square equal to 0. So I've just rearranged the terms. Now if you observe the first three terms, it is similar to the first identity that we have written here, this one. So we have 4x square plus 4bx plus b square. This can be written as 2x plus b the whole square. Okay, and then we are left with minus a square. Now if you see this 2x plus b the whole square minus a square is similar to the second identity, p square minus q square. So we can write it as a product of two factors, 2x plus b minus a into 2x plus b. Minus of minus a would become plus a equal to 0. So there are two factors, we can equate each of them to 0. First factor 2x plus b minus a is 0, or you will get 2x as a minus b. So x will be a minus b by 2. Similarly, we can take up the second factor 2x plus b plus a and equate it to 0. This will give us 2x is equal to minus of a plus b. X will be minus of a plus b by 2. So the answer is x is a minus b by 2. That is one factor. That is one root, and the other root is x is equal to minus of a plus b by 2. So we have solved for x. Just rearrange the terms in the equation and try to apply the known algebraic identities and simplify it as a product of factors. Now, ninth question. Write all the values of p for which the quadratic equation x square plus px plus 16 has equal roots and also find the roots of the equation so obtained. So it's a 3-mark question. The equation given is x square plus px plus 16 equal to 0. So if this equation has equal roots, the discriminant b square minus 4ac should be equal to 0. So b is nothing but p. So p square minus 4 into a is 1 and c is 16. So p square minus 4 into 16 will be 64 equal to 0. P square is 64. So p will be plus or minus 8. So we have two different values of p for which this equation will have equal roots. Now we've been asked to find the roots of this equation as well. So first let's use the value of p as positive 8. If p is equal to plus 8, what will be the equation? X square plus 8x plus 16 equal to 0. So the roots are given by, since the condition is that the roots are equal, the roots will be minus b by 2a, which is minus 8 by 2 minus 4. So for this equation, when p is equal to plus 8x, the roots are minus 4. And in the next condition, when f p is minus 8, the equation will be x square minus 8x plus 16 is equal to 0. Again, the equal roots will be minus b by 2a, which is minus of minus 8 by 2. So it will be 8 by 2. So x will be 4. So the values of p is plus or minus 8 and the roots of the equation so obtained are minus 4 and plus 4. Let's move on to the next question. Question number 10. If the equation 1 plus m square into x square plus 2mcx plus c square minus a square is equal to 0 has equal and real roots, then show that c square equal to a square into 1 plus m square. Again, it's a 3-mark question. So we have been given with the equation, and also the condition given is the equation has real and equal roots. So equate the discriminant to 0. Discriminant is b square minus 4ac. B is 2mc. So 2mc the whole square minus 4 into a is 1 plus m square and c constant term is c square minus a square. So here the equation is already in the standard format, a into x square plus b into x plus a constant c equal to 0. So we have just substituted the values in the discriminant formula and equated it to 0. So if we simplify this, I think we will be able to prove this statement. So expand this 4m square c square minus 4 into c square minus a square plus m square c square minus m square a square. So 4 is common. Let's divide it by 4 throughout. You will have m square c square minus c square plus a square minus m square c square plus m square a square equal to 0. I've just divided the entire equation by 4. So m square c square and m square c square is cancelled. We are left with minus c square plus a square plus m square a square equal to 0. So let's have a square common from these two terms. You will get 1 plus m square, and let's send the c square to the other side. It will become positive c square. So we have proved that c square is equal to a square into 1 plus m square. Just write the discriminant and equate it to 0, because the condition given is the equation is having equal and real roots. Hence we have been able to show that c square equal to a square into 1 plus m square. Let's go on. 11th sum. If AD is not equal to BC, then prove that a square plus b square into x square plus 2 into ac plus bd into x plus c square plus d square is equal to 0 has no real roots. So again, the equation given is already in the standard format. This is ax square plus bx plus constant term c. So let's find what is the discriminant for this equation. B square minus 4ac. So the discriminant is b square will be 2 into ac plus bd the whole square minus 4 into a is a square plus b square and c is c square plus d square. Let's take out minus as common and rewrite the terms. It will be 4 and minus 4 into a square d square minus 2abcd minus plus b square c square. Now we can see that we can simplify this and write it as ad minus bc the whole square. So our discriminant is minus 4 into AD minus BC the whole square. Now, if AD is not equal to BC, if AD is not equal to BC, then the discriminant will not be 0. There will be some value for this AD minus BC, and when we square it, it will always be a positive number. When multiplied with minus 4, discriminant will always be less than 0. So, as per the question, if AD is not equal to BC, then our discriminant minus 4 into AD minus BC square will always be less than 0. So, when discriminant is negative or less than 0, what does it mean? The quadratic equation has no real roots. 12th sum, solve the following quadratic equation for x. 4x square minus 4a square x plus a power 4 minus b power 4 equal to 0. 3-mark question. Equation given is 4x square minus 4a square x plus a power 4 minus b power 4 equal to 0. So again, let's express this as product of factors. So for that we will simplify this. First three terms can be written as 2x minus a square the whole square. Because when we expand, we will get 4x square minus 4a square x plus a power 4. We are left with b power 4, which can be written as b square the whole square. So this is of the form p square minus q square. So it can be written as 2x minus a square plus b square, which will be p plus q into 2x minus a square minus b square equal to 0. So there are two factors and we can equate each of them to 0 and solve for x. So 2x minus a square plus b square is 0. So 2x will be a square minus b square and x will be a square minus b square by 2. This is one value for x. And let's equate the second factor to 0. 2x minus a square minus b square equal to 0. 2x will be a square plus b square. Hence x will be a square plus b square by 2. So we have got two values for x. A square plus b square by 2 and a square minus b square by 2. So we have solved 12 different sums from the previous year board exam papers. And now I have given one question here for you all to practice. Find the non-zero values of k for which the quadratic equation k plus 1 into x square minus 2 into k minus 1 into x plus 1 is equal to 0 has equal roots, and also find the roots. So it's a 3-mark question from 2015 board exam, and I've also given the answer for you guys to work out and then check. If you have any doubts in solving this question, do write a comment. I will immediately respond to you. So that's the end of this video. Hope it was useful for you. To practice other chapters, do visit the channel and check the different playlists. Please subscribe to the channel and also press the bell icon for regular updates. Thanks for watching. Keep practicing. Meet you soon with another video.